Today we're looking at loops. Do you want to write less code? Are you sick of copy pasta? Well, you just need to learn to loop. As we looked at before, there are a couple different types of loops that we have available to use in class. The first one we're going to be looking at today are the undefined time loops. These loops are the while and do-while loops. So-called undefined time because we don't know how long it'll take to solve the problem attached to the loop that we're using. Because they're undefined, we have to make sure we specify in advance how long that it is going to do this actual loop. And there are a couple different parts we'll be looking over, and we look at the actual loop structure for this. The basic idea on a while loop is that the loop will execute until the condition, or the fancy word for test, fails. Because of this, and the way the actual loop structure is set up, it is very easy for a while loop or a do-while loop to become infinite if you do not properly set it up. Finally, the idea that loop components on a while loop and a do-while loop are separate from the actual header of the loop itself, and as such, you must make sure are put together in the proper order. Now, this order is not Java specific, but rather it is Henriksen specific, and we're going to go over those parts right now. So we have our while loop test method right here, and for a while loop, the first thing we have to do is, before we actually write the loop, the first thing we need to have is we must declare our looping variable. Notice how I have it right here inside the method, but before the actual loop happens. And again, because it's in a method, we must have a value attached to that, especially since we're using it with a loop. The next part of the loop that we have is the actual header itself. And for a while loop, it is simply the header with the keyword while, the parens, and then the condition of the loop, aka the test. What must evaluate to be true if we want to continue doing that loop. Then we have our squiggles, which match where we're going to actually be dealing with the code, which is the body of the loop. The body of the loop is what we will repeat over and over again as we actually execute that code. We'll start at the top, work our way down, and repeat until the loop condition fails. In this case, we have a JOption pane that pops up showing the condition variable, loop count, and how long we've gone through the loop. The rule we have for Henriksen's class when writing loops is that last line of code in your loop will be the adjustment or the incrementation or update of your loop variable. There are a couple reasons for this. First reason is it's easy to see and remember when it's right there. By having your loop update variable as the last line of code inside your loop, you know exactly what is being checked before you actually go back through. By having the last line of code be the update or the incrementation of your loop variable, you know exactly what is happening before you run that actual condition again to see if that loop should execute for the next time. Second, by having in the same place, you always know where to check your own code and that of others to make sure that their code is also properly structured. So in this case, we have a loop count set at 0, and our condition is as long as loop count is less than 10. So with loop count being set at 0 and loop count test condition being set to be less than 10, this loop will go through until the loop is no longer less than 10. Therefore, any number that is 10 or greater would cause this to fail. So if loop count suddenly became 3 billion, it would fail. Since it's an int, obviously it can't make the 3 billion mark. Finally, we have our body of the loop. Again, what the actual loop is doing, what's happening every time it executes. In this case, we have a pop-up window. Then inside the body still, we have our incrementation or update of our variable. In this case, loop count plus plus. Again, the plus plus allows the variable to have one added back into it and stored into the same variable name. So loop count starts at 0. Loop count plus plus will move that value up to 1. At that point, we reach our end squiggle. So we go back up to the top of the loop. Notice that loop count is less than 10. 1 less than 10. That is true. So I continue going down through the loop. This process will repeat until we have the loop count is no longer less than 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. At the 10th loop, well, loop count 9 is at 9, becomes 10. We go up here to this point. 10 less than 10 would return false because 10 is not less than 10. Therefore, at that point, we would skip over the entire loop body and do what is after that. In this case, there is nothing. So the loop itself will loop as many times as it will pass the condition or pass the test, returning a true value. Let's go ahead and test that out. In our start method, we'll add the while loop test. call the method by having the parameters right there of 0, and save the method and hit play. As you can see, there's the 0th time for the loop. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the 10th time, the loop fails and it's over. Easy to go. The next loops we have are defined time loops. This is the for loop, and personally, my favorite. I like this loop for a variety of reasons, one of which, though, it requires that you plan out and know what you're going to be doing in advance. The for loop executes a defined number of times, as you specify inside the header for the loop. And this can be any set of times. Additionally, because the for loop is self-contained, all of its components, the initialization, the condition, and its update or incrementation are all within the header, and you can verify them very quickly. With this as well, you can also set the for loop to do any set of different circumstances. Every other number, every third number, numbers if they wanted to, the ending queue. You can specify this to do any certain number of ordered times as you wish, as long as you define it with the proper adjustment of its incrementation or update and the condition. Let's go take a look at them. As you can see, the loop itself is much smaller here than the previous while loop. We have our combination header here, where it has the incrementation, the initialization, and its condition all in one single line. And it's first the initialization, loop counter is equal to 0, followed by a semicolon. Then the condition or test, loop counter is less than 10. Again, that same test we had just used with the while loop, followed by our incrementation, still in that same chunk, but not with the semicolon, loop counter plus plus. With a for loop that is all defined at one single time, right there, ready to go. So we know immediately when we write this loop how many times it's going to happen, what we're going to do each time we end the loop to update to go to the next condition. Our body loop looks just the same, jabbchampagne.showMessageDialog with the loop counter variable. The only difference that we have with this is there is no declaration of a variable here before the loop, nor do we have as our last line of code an incrementation value being adjusted to our loop. That is all handled in one single statement as part of our actual loop header. To test this out, again, all we have to do is change this while loop test to a for loop test. Save and play. And as you can see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it exits. This loop is the exact same functionality as our previous loop, the while loop. Our difference is the while loop's structure requires separate components at different spots, whereas our for loop, that same structure is contained in one single location of the loop header. The body loop is exactly the same, it's just a little bit condensed inside the for loop. Now again, please remember, smaller code, not necessarily better code. Finally, we have our structure-based loops. This is the for each loop, also known as, in official Java speak, the enhanced for loop. The enhanced for loop or for each loop has a completely different style and structure than you would see in the traditional while and for loops. In fact, the enhanced for loop or for each loop was not added to Java until Java 5. The first thing that is different is that the use of a for each loop requires a structure. This structure can be an array list, or any member of any structure class, including those part of the collections class that we will see later. Additionally, when using a for each loop, there is no condition that is evaluated. There's no test that happens. Rather, the body of the loop will happen to every single instance of the value that is stored inside the condition. Rather, the body loop will execute for every single instance of the item stored within the structure that is being looped over. Hence the term for each, for everything inside that structure. There are also no counter. Because of this, there is no way that we can actually say that we're going to go in any specific order. Since we are using array lists or arrays for our first few for each loops, these are going to guarantee that they will go 1, 2, 3, 4, 5 of the actual items specified inside of that array list or array, However, if we use other data structures, such as a priority queue, queue, map, or hash table, because those structures have no order, or the order is specified differently than the actual one you would see when looking at the data structure, we will actually not have them expected to go in any guaranteed order. So again, with the structure-based loop, which is the for each loop or the enhanced for loop, it is very different and has separate requirements. Let's go take a look. We have in here, in our enhanced for loop test, we have declared an array list of string objects called myWords, and we have added first, second, and third to that list. Then, looking at our header, it is clearly different than our previous for loop. We have for, a variable type and variable name, the colon, and then the name of the structure we're actually looping over. Note that there is no actual use of a condition. There is no counter. It simply says for the type of variable and the structure in use. And then as we look inside the body of the loop, it's also a little bit different. In our J-option pane, the current word is current word. There is no change to the variable. There is no update that is necessary. Rather, with a for each loop, it automatically updates itself for each value inside the data structure that we're using. As you can see, we have right here, we've added first, second, and third to our array list, and so it will go through our array list going through first, second, and third. And let's take a look at that. The current word is first, the current word is second, the current word is third. Structurally, very different. Again, let's compare the two. Our previous for loop has a initialization, the condition, and then incrementation as one single line for its header, whereas our for each loop simply has the type and variable, then a colon, and then the actual data structure we are looping over. So the enhanced for loop, or the loop that is a structure-based loop, does not use any counters, does not use any conditions, and in fact there's no spot to use them in there. Additionally, with the for each loop, we must use it for everything inside that array list. If we were to do something on an array list inside the for loop, we could choose to do only the first, third, and fifth items of that array list, or only the even numbers of that array list, or other parts that we want to do with, say, for example, the contents that end in Q. Whereas in the for each loop, we will do it for everything inside that array list, regardless of which item is stored. So the structures are quite different, and we'll use them some more as we go through. As a review, we have our while loop. A while loop has a declaration outside of the loop itself, the keyword while and its condition inside the parens, followed by the loop body. The last line of code of the loop body must be the update or incrementation of that loop. On a for loop, a little bit different, we have our initialization, our condition, and incrementation all as one single line inside the for header, followed by the actual body of the loop inside the squiggles. Then our structure-based loop, or the for each loop, we need to have a structure that we must be using. In this case, we were using an array list of strings. The structure loop itself specifies the variable type and its name, and then the data structure that is being used. And inside the body, it will affect every item that is used inside said data structure. We also have the do-while loop, not used as much in class. The do-while loop looks very similar to the while loop. It declares the variable outside of the loop. The body loop still has the same basic structure. And the last line of code inside the loop is the incrementation, just like a while. However, because it does this first before making the test, the last line of the while has a semicolon after it, which is dissimilar and different from every other loop. No other loop will you place a semicolon after the header for the loop. That only happens on a do-while loop because the end of that statement happens at that point of the do statement. The loop then would recur over and over again until count is no longer less than 10. So the loops that are do while, and for all test the same basic structure, looping over 10 times that we see here, just using a different method to do so. Functionally the same, structurally different. The for each loop, our structure-based loop, is structurally and functionally different. Looping instead over a structure, in this case an array list of strings, where it loops over each word inside array list until it is complete, with no condition or counter to use.